This presentation will cover the 7 basic comprehensive steps to submit a cheops proposal for this guest observer program. And these steps are designed to guide you through all the necessary information and documentation, but you need to know about a successful submission of your proposal. But before diving in all these 7 steps, let me show you what cheops can give you for your scientific research and why use this guest observer opportunity. Unlike many other observing programs, cheops has only 50 GTO reserved targets, so all other targets are available or open to the community to apply time. 30% of the science observing time is dedicated to this guest observer program, and we have a rigorous review process, so the proposals go through double anonymous peer reviews, ensuring fair and unbiased evaluations. And you don't need to install anything on your computer, so all the documentation is available from the web page, and there is a cloud-based target visibility checker, which will show you later. So cheops is a space-based ultra-high precision photometry space telescopes. So for brighter objects that are between 6 and 9 magnitudes, in 6 hours you can reach like 20 ppm precision. For a bit fainter stars, like between 9 and 12 magnitudes, in 3 hours you can reach like 85 ppm precision. And there is a wide sky coverage. More than 50% of the sky is observable with cheops. And to show, in the next few slides, I will show you a few highlights of scientific research with the cheops Space Telescope. For example, Hoyer et al. An exoplanet which is orbiting a sun-like star with less than 1 day orbit, and they found that this planet has a metallic reflective clouds, making this planet the shiniest exoplanet ever found. Cheops also explored these so-called mini Neptunes. These planets are in sizes, they are between Earth and Neptunes, and they are orbiting in a closer orbit like our Mercury. They basically studied 4 of these kind of objects, which are one of the most common objects that we know now, exoplanets in exoplanet terms. Sorry. Cheops also unlocked a really rare 6-planet system where the planets are in resonance. So in every few orbits, they are aligned. And these results were shown in a Nature paper recently. So let's go through the 7 steps you really need to know. The very first step is the registration. So I will show you in the presentations and then switch to my web page to show what to do and how to do these steps. So first step is the registration. You go to the proposal submission. So you go to the guest observer web page and go to proposal submission and click on the registration. And you follow all the necessary steps what is written. So fill in your email address and everything. And then you will create this so-called Cosmos account with this web page. I already have, so I will sign in to see more. And with this Cosmos ID, you will have access to other ESA Science user services like ESA Sky, Helpdesk, and ESA Data Labs. The next step you need to know is the coordinates, and I will show you to make sure that you will use the right coordinates to avoid any problem later on with the, sorry, I will switch back, with the submission of your proposal. So CHEOPS is using the ICRS coordinates with J2000 epochs. So Simbad will resolve these coordinates for you. But if you try to apply with a target which has, for example, Simbad couldn't resolve, be aware that Gaia and, for example, ExoFoc coordinates are not this one. So you have to make sure to find the correct coordinate for your targets. So this can be found. You go again the guest observer webpage, the proposal submission, and the target status checker, and click on it. And you type in your target. For example, I will show you this one, this 189377, and just click resolve target, and it will give you the correct or the right coordinates for your target. And you will have to use this coordinate all the submission process. The next step is the visibility checker, and I will give the words to Bruno. He will explain and show you all of this, and I will stop my share screen.
To activate the visibility checker, one needs to come to Data Labs. So in this same website that Alice was showing, visibility checks, one can click here on this button, visibility checks powered by Data Labs. For this, they should have created a Data Labs account. So the process that Alice presented, then there's a second registration block just below the one that Alice showed, where you request your account to be registered to Data Labs. And once you have it, you can log into the system. The website is datalabs.esa.int. You need to come to this Flask button here. Click on Launch New. Then you have here a list of Data Labs of various types. Search for the ones that have the word CHEOPS on its name. You get these two. So I'm going to show quickly the two of them. cheops-bis is the simplest to use. I click on it and I click here on Launch It. This will create this card that I need to click as well to kind of actually start the virtual machine, this application. Okay, so now it started. You see, I got this terminal window, which description of which the title of the application, cheops-bis. This is the visibility tool. It basically allows you to calculate whether a target is visible by cheops and when. It gives you the example use. You need to press enter to get the prompt. You see, then you just need to type cheops-bis. -- target _ name, then like between quotes the name of the target you want to observe, UI 270. So that's example because I think this target is not visible. Okay. Try again. Yep. So let's try now, for example, as they said, 51 pegs. So it's just target name and then the name of the target within quotes. And then this will give you these two figures. Will show you the sky position of that target compared with the visibility of cheops. This left-hand figure here is the position of the target we've selected, which is marked there, and then this blue symbol shows the position that the sky visible by cheops at the time shown at the top of the screen. And then there is this slider function that you can use to scan how these visibility windows move throughout the year. And then here on the right, you can see this figure shows the efficiency as a function of time over the year. Then you see these gray areas are periods of time where the target is not visible. And then the green and white areas are the time range in which the target is visible. And you can see in these two figures the efficiencies that cheops would have for observing this particular target for the bright and faint cases. So you can see that this particular target 51 Pegasi is observable from mid-July to mid-November, and it starts with an efficiency of around 55 and it reaches 80 somewhere in early September. So this is basically what you need to know, what you need to do to find out whether your target is observable and when. This figure also shows you in these green shaded areas the times when the target is also visible by JWST for those who want to have simultaneous observation. But in principle, this function here is a slider button that allows you to move this visibility function to look at what's the visibility of cheops at the different days on the year. Then this figure here also shows the Kepler field, the Plato field for reference, and the K2 fields in case that those are useful. So that's the first application that you can use, cheops-BIS. But then there's another one which we can also look at, which is called cheops-SFC. This one, just click on launch it, and then you click here. This is a more sophisticated application that actually calculates exactly the visits that are possible. So cheops-BIS gives you this overall simple view of when the target is visible by cheops. cheops-SFC is the actual planning tool, which will check whether the observation is visible and at which exact times and with which exact visits. So now it's launching. You can see the application is here. Essentially, what you need to do is to basically ingest an observation request. So for that, it will open this Finder tool where you can search for one of the observation requests. You have two templates here that you can use. One for time critical observation and another one for a non-time critical observations. We can load one of them. Here you can see we've successfully ingested the observation. Is time critical. The target is 55 Cancri. You have the right ascension and declination and the magnitude. You have the visit duration and then also the earliest start, the minimum requested efficiency, and the transit time and the period. Okay. And then there you have these two numbers here, which are the earliest observation start phase and the latest observation start phase. And then you can also define critical phase ranges. Once you have uploaded this, all you have to do is to come to analysis and in visibility check something at the end of the year. So let me actually choose December. This is December. sorry, I should have prepared some good ranges. This will, I mean, you can also give like the full period of like the full year, but then it will take very long. Here we're just entering like 15 days. But this will actually generate the exact visits that you want, that the exact visits with the start time. You see here it works. So it found 15 visits in this period between the 2nd of December and the 17th of December. And you can see here like the exact start-stop time, the duration of the visit, the efficiencies that you will obtain. And then each of these observations here are the various possible visits for that transit in particular. And you can see here in this SSA, these are the South Atlantic anomaly passages. These are like these 3 rows here show times when the observations cannot be made because either the satellite is flying over the South Atlantic anomaly, or it's affected by the Earth limb, or there's a straight light. So this determines the efficiency. And you can see this is basically the information you need to put in the technical justification of the proposal. And yeah, back to you, Alice.
Okay. I share again. Can you see it now? Okay. So I just wanted to go back because maybe it was too small letters when Bruno typed in. So when you want to have the visibility check, so you type in this cheops with target name and your name, and you can find your target visibility. So the next step is the target status check. So you have to verify whether your target is not a reserved object. And with this, you will find how to figure it out. So you go back to the proposal submission and the target status check. So I will show the previous target I typed in. So you have the coordinates. So result with the symbol, you have the coordinates, and you will click on the search button. And you will see a green light if this target is not a reserved target. So it says that geo proposals for these targets are welcome. But for example, I will show you another object. So you reserve the coordinates and then search. For example, this object is reserved target, so you can't apply for time for this one. Another step to check, sorry, before checking the others, so you have to submit with your submission about this that your object is not a reserved target. So make like a screenshot or something, and you will attach to your proposal this. And before submitting, you also go to check to the archival of the whether there is an archive data about this object. You will do this again, the proposal submission page and the target status check, and this will go you to the archive data. And again, you type in your target. For example, I will show you again this target. You will resolve. It will give you your coordinates and submit the query. Wait a little bit, and it will show you if you have any previous data with the cheops. So you will see, for example, about this target, you will find some data. You can still apply for time for an object which have previous data, but you really have to show why you need more data and not enough. These data are not enough for you. Okay. So the next very important step is the exposure time calculation. So you need to find a correct and right exposure time for your data. And for this, there is a really good web page to calculate this one, and I will show you just a sec. Again, the guest observer program page, proposal submission and exposure time calculation. You click there. And you need to fill in a couple of input parameters for your target. So I will show the previous HD189377 data. I have collected these. So you have to type in the Gaia G band magnitude of this object is 7.4 magnitudes. You need the effective temperature of your star, which is 50 Kelvin in Kelvin, and you have to choose the spectral type of your object. This one is a K2b star, and here you can find the actual exposure time, but you have to choose rightly. This can be between 0.001 and 60 seconds. And I will show you now what happens if we type the 60-second, the maximum time. And you also need to fill in the coordinates of your object. As I showed you before, the ICRS J2000 coordinates. Sorry, dot. And these are the coordinates. There are some additional parameters which are not necessary. It's only depending on if you want some further data to specify. For example, you can find a defined interval of your observations, or you can use the sorry, the cheops band flux of your object, or you can also specify an efficiency of your observations. But I will show these, I will leave them empty. So then when you typed in your input parameters, you click on the calculate button. So the first and very important things you need to know that there is no pixel saturation within the PSF peak. And this is shown on this line, the saturation level at PSF peak in percentage, which can be larger than 100%. So now we can see that it is 500%. So this exposure time is too long. So I will change to 10 seconds and calculate again. And now you can see that the saturation level is much lower. It is the best to stay below like and around 85%. So this will give you enough margin to avoid the saturation and by minimizing the instrumental noise. And below this value, you will find 2 or 3 tables depending on your input choices. So in the first table, you will find some different noise levels, assuming 100% efficiency with different exposure times, like 1 minute, 10 minutes, and 30 minutes, 1 hour, 3 hours, and 6 hours. And then if you didn't use any additional parameters, then you will find 2 tables, one for assuming maximum efficiency and one for median efficiency, and you will find different noise levels. If you use additional parameters, I just show you, for example, if you need like, I don't know, like 60% efficiency, then for below the first table, you will find all the noise levels for this parameter, this efficiency. And if you are happy with everything, then you will click on the export results, and you will get a PDF file like this about your exposure time calculation, and you will have to attach this PDF file to your submission. I will show you where to upload this one. Okay. The next step is basically to download the proposal templates that you can fill in. You again go to the desktop server web page, and you will find them in the proposal submission, and these are the proposal templates. And you will find 3 templates. These are simple doc files that you just fill in. For example, I will click on the scientific justification, and this is how it looks like. And you will remove the red parts and fill in the all the, for example, here the justifications. There is this team expertise management for web page, document, sorry. I will show you here. So with this, you will list all your team members and expertise of your team members, and how you plan to reduce the data or analyze the data. And this is not anonymized, so you can freely write in all your team members. But the other 2 documents, the scientific justification and the technical justification and implementations, it's really important to respect that there is this dual anonymous reviews. So make sure that no one can guess who is the proposing this target or this project. So, for example, don't write anything that in Smith et al. We showed this and this, so something like that. And finally, about the submission phase, to submit your proposal in the phase 1 submission, you again go to the desktop server page, proposal submission, and go on submission phase 1. And click on the submission phase 1, and you have to also log in with your Cosmos ID, and click on the AO6 call to submit your proposal. Now you can see I don't have any submission started, so click on the plus sign to start your submission process. At the first page, you fill in all the PI details, so name, affiliations, and all these kind of informations. And the team expertise and management plan document is uploaded here on this first page. And then when you filled in, you click on next. You will here there is some additional contacts, and all your collaborators data are filled in this page. And then when you filled in, you click on the next one, and here is all the proposal details. So you fill in the title, categories, and write your abstract, and you will upload all the necessary documents for your proposal. So the scientific justification and the technical justification. So as told you before, these are anonymous reviews. So these documents come here. You can upload the exposure time calculation results here, and also about the target status check, so to show that it is not a reserved target. And finally, you will fill in all your information on the next page about your targets, so names, coordinates, how many visits you want, and how many orbits per visit you need, and all the necessary information about your targets. And when you filled in, there is some agreements you have to click in, and with the finish button, you will submit your proposal and then wait for the results. I think that's it.